Hi everyone. In the last video we looked at how to find the inverse of a matrix, and you may be asking yourself, why are we even doing that? Why are we even finding the inverse of a matrix? Well, this is going to be really helpful when we talk about solving equations, which is what this video is going to be about. So let's say we have an equation that looks like a times x equals b. So this equation is a little bit different than one that we looked at earlier, where x just had a scalar going along with it. Here, x is being multiplied by a matrix A. Now, you may be thinking to yourself, well, we're supposed to get x all by itself, which means we need to move the a to the other side. But the problem is we never talked about division. In fact, we said we can't divide with matrices. So that's where A inverse is going to come in handy. We said that multiplication with matrices is not commutative, so what's going to matter is we need to talk about multiplication on the left versus multiplication on the right. Those two things are going to be very different. But one thing that's nice about inverses is that when you have A and A inverse, when you multiply them together, you're going to get something called the identity matrix, which we're going to call capital I. This identity matrix is kind of like the number 1 when we talk about real numbers. So just like how 3 times 1 is 3, whatever number you have times 1 is going to be that number that you started with. When you're talking about matrices, A times the identity, any matrix A times the identity is going to just be A, because we're treating the identity like the number 1. Now, A times A inverse is the identity, but it also works the other way around. That A inverse times A also gives you the identity. We said that matrix multiplication is not commutative, but when we have inverses like this, A times A inverse and A inverse times A, then in that case, we do have matrix multiplication being commutative. So when we start with an equation like ax equals b, and we want to solve for x, what we're going to do is we are going to multiply on the left-hand side of each side of the equation by A inverse. So it's going to look like A inverse times A times x equals A inverse times b. We're doing the same thing to both sides. We're multiplying by A inverse, but specifically we're multiplying by A inverse on the left. Now, the reason we want to do that is because A inverse times A, well, that shows up here. That's just the identity. So this is I times x equals A inverse times B. And what's I times x? Well, we said earlier that any matrix times the identity matrix is itself. So I times x is just x. And now we do have x all by itself on one side of the equation. And if we know what A inverse and what B is, if we know what A inverse is and what B is, we can multiply these two together and find out exactly the matrix X. That will be our solution. So whenever we have AX equals B, we're always going to multiply on the left-hand side of both equations by A inverse. But in order to multiply by A inverse, we need to actually know what A inverse is. So let's take a look at a specific example. Let's start with A being the matrix 2, 4, 3, 7. Remember, A needs to be square in order to even have a chance of having an inverse. So here's a square matrix A. Now, we could use our calculator to find the inverse of this thing, but this isn't too bad. Remember, the formula says A inverse is, it looks like 1 over, and then we take A times D minus B times C. It looks like 1 over 2 times 7 minus 4 times 3. And then we multiply by the matrix that looks like 7 up here, a 2 down here, a negative 4, and a negative 3. If you don't remember this formula, go ahead and take a look in the last video about how to find inverses, and hopefully that will refresh your memory. So here, this is going to look like A inverse looks like 1 over, we have 14 minus 12 is 2, and then multiply by the matrix 7, negative 4, negative 3, and 2. So this is a scalar multiplied by a matrix. You're going to end up with the matrix 7 over 2, negative 2, negative 3 over 2, and a positive 1. So here's our A inverse matrix, okay? And then for this example, we're going to also start with a matrix B that looks like 2, 1, -5, and 0. Okay, so you'll notice before I even set up the equation, I found what is A inverse. If you have an equation that looks like AX equals B, remember we need to know what is A inverse in order to be able to solve this thing. So A times X equals B, well, we're going to multiply on the left on both sides of the equation by A inverse. There we go. Now, what's always going to be the case is that A inverse times A gives you the identity. So we have I times X equals A inverse times B. I times X is just X. And then we want to know, well, what are we left with on the right-hand side? Because that should be the matrix X. That's our answer. Well, now that we know what A inverse is, we found that at the beginning, and we know what B is, we need to first of all even check, are A inverse and B compatible with multiplication? Well, A inverse is 2 by 2, B is 2 by 2, so we can actually multiply these together because those middle values are the same. And if we go ahead and do this in our calculators, what we'll find, if we go ahead and go to our matrix commands, and you'll see that for matrix A, I have A inverse typed in as the first one, 3.5, -2, -1.5, and 1. And then for the second matrix, for matrix B, we have this typed into matrix B, 2, 1, -5, and 0. So we're going to take A inverse and multiply by B. That's going to give us our matrix X. That is our solution. So in our calculator, it's the first matrix that we have typed in times B. Now we can't do B times A inverse. Remember, multiplication is not commutative here when we don't have A and A inverse with each other. Here we can't do B times A inverse. We have to do A inverse times B. So when we do this, we find this new matrix, which is 17, 3.5, which is 7 over 2, -8, and then -1.5, which is -3 over 2. And so here is our matrix X. And we could check that this matrix X is actually the correct solution to the equation, because if we multiply A times X, we will get the matrix B that we started with. So this matrix X does give us a true equation here where the left side equals the right side, and that's what we have as our solution. All right, thanks for watching.